Good morning, students. In the previous classes, we have discussed applications of dimensional analysis. I hope all the applications are clear to you now. Now today, we will discuss few limitations of dimensional analysis. Although with the help of this method, we have derived many physical quantities, but few limitations are there in dimensional analysis. Let me discuss them one by one. First of all, this method gives no idea, no information about dimensionless constants used in the formula. What can be the dimensionless constant? It can be any constant numerical value, 1, 2, pi, e, any of the value used in the formula. See, if you have this particular result, t equal to 2 pi under root of L upon G, and if you want to derive it, so basically what you will obtain that t is proportional to L raised to the power 1 by 2, G raised to the power minus 1 by 2. But you cannot get any information about this 2 pi. We can simply get proportionality dependence on L and G. Similarly, in this result also you get no information about this pi by 8. That's why it has been said that it gives no information about dimensionless constant used in the relation. Second point, if a quantity depends on more than 3 factors having dimensions, obviously the quantity must have dimension formula. The formula cannot be derived. How can we explain it? Simple terms we can say that when we have to derive a relation, that factor must be depending only on 3 factors, not more than that. Let me take an example. See here, as we have done, the derivation of rate of flow of liquid through a pipe was proportional to pressure gradient, radius and coefficient of viscosity. We have not taken that volume, that rate of flow is proportional to pressure or length or r or eta. If you will proceed like this, this will never be derived. Why? Because here the factors are more than 3. Why we cannot derive it? See, basically, if we will substitute the dimension formula of all the quantities given, these are only expressed in terms of m, l and t. No other quantity or no other fundamental unit will be used. So, if there are 4 variables, there must be 4 equations, but here we will get only 3 equations. So that is why we cannot derive a quantity which depend upon more than 3 factors. In the similar case, if we have if we will revise the concept we have done in derivation, that was derivation of Reynolds number. In that also we have taken that Reynolds number is proportional to diameter raised to the power 1. We have taken, this was assumed to be given. But if it was not given, we cannot derive that relation also. So now, after this, coming to third limitation. We cannot derive the formula containing trigonometric functions, exponential functions, logarithmic functions. It means which having no dimension formula. What does it mean? Exponential functions we have introduced in the applications in the homogeneity principles numericals. So that we have taken that e raised to the power minus k, theta, whatever be the value, we treat this to be dimensionless. Trigonometric functions, suppose we have the relation h equal to 2s cos theta upon r rho g. If you have to check the correctness of the relation dimensionally, we can easily do. Why? Because theta is an angle, it is dimensionless. But when we have to derive it, we cannot derive it. Reason being mixture of the 2 limitations, as there are 4 factors here. Another thing is, this way, if by some certain means, if we take ratio of surface tension or length, or by some another means we are deriving by converting 4 factor into 3, but still we cannot get any information about this cos function. This is trigonometric functions. So here this trigonometric function, exponential and similarly logarithmic functions which are taken to be constant, they cannot be derived by using this dimensional analysis. Next is, this method fails to derive composite results which are the composite results, which can be obtained by adding or subtracting many different physical quantities or relations. Like you are observing here, S equal to ut plus half at square. V square minus u square equal to 2as, or V equal to u plus at. Many relations can be. See, if you want to check the correctness, you can easily check. But you cannot derive the relation as an addition of these two. If you want to derive, you will either derive S proportional to ut or S proportional to at square. But this result you cannot derive. This method gives dimensional correctness of physical relation. This point I have not mentioned here. You can understand as one more point is there. As we have taken that composite results cannot be derived. Only we can check the correctness of the relation. But if we take S equal to ut plus gt square or S equal to 2ut plus 3 by 2 gt square, whether these two relations are also correct? Physically we will say, because we have studied this relation in class 9, so we can judge that these are not physically correct. But if you check their dimensional correctness, you will find it to be correct. So this is also the limitations. A relation which is dimensionally correct is not physically correct. This is also imposing a limitation on dimensional analysis. So this is also one point which I will add here. Next is, it gives no information whether a physical quantity we are deriving is scalar or vector. As you know the concept of scalar or vector quantities, but this dimensional analysis will not give you any information whether force is a vector or work is a scalar quantity. This you will study later on, but dimensional analysis fails to give such informations. So these are 6 limitations. I have added that one which I have not written previously. It fails to explain a dimensional correct relation to be physically correct. So sometimes a question can be there, discuss the limitations of dimensional analysis. Basically when such kind of question is there, just you can take that the limitations point you have to write minimum 4. If it is in the 2-mark question or 3-mark question, then you have to write all the 6 points. So you have to learn all the points carefully. Now after this dimensional analysis, next is error and its detection, error and its measurement. So basically what is error? What you understand by the term error? See, error is basically it is uncertainty in measurement. Let me take simple examples. You are doing some experiment, your experimental result and the standard results are not matching. We can take one example, that acceleration due to gravity, as we all know, that is 9.8 meter per second square. And experimentally we are performing the experiment, when we are getting the results, it comes out to be 10.2 or 9.6 or 9.4 or 10. There can be different values. So basically this difference in experimental value and standard value, this is the error. So here we will learn how to correct the error, how to find such kind of error. First of all, we will understand what is error, what are the different kinds of error. So error, it is the difference between measured and true value of a physical quantity. True value, it means standard value. Measured value, which we have obtained by certain experimental technique. The difference of these two, it will give you error. Now, there are different kinds of error. First is types of error. What are these? Constant error, systematic error, gross error, random error, least count error. Usually when you will discuss all these in detail, you will find this gross, random, least count. These are somehow you can relate it with the systematic error. This is the main error. So let me take one by one. Now, constant error, as the term indicates, error which is constant, which remains same. Basically, this is an error which affects each observation by the same amount. This is called constant error. that error which affect each observation by the same amount. So how it happens? That means same error repeat every time when you are performing the experiment with the same apparatus, and the same kind of error will continuously coming in each measurement. Such error. Now, what can be the reason for their occurrence? There can be certain fault in the instrument. Like there can be such errors are due to faulty calibration of measuring scale of instrument. See, this is a scale. You can all see this is a scale. Now, if two possible causes, that if you are taking its starting point, like this is 0, 1. If suppose one of the point can be, suppose in between 0 and 1 or 1 to 2 and so on, instead of 10 division, by chance this is the marking error while designing this scale, that 9 points have been given in any of these division. It's not necessary that everywhere it will be given. It may be the fault within the scale. If 0 to 1 there are 10 division, suppose 4 to 5 there are 9 division. Very rarely this happens. So, same kind of error will be occurring when you will measure the length of any object. Likewise, if suppose this corner is cut, suppose you have to take the measurement not from 0 and from 1. So, every time if you will do the measurement, suppose you have to do the measurement of an object whose length is 5 cm, and you will do it with the help of a scale whose 1 cm part is just not present here. So what you will get? You will get measurement to be 6 cm. So although we can apply correction that 1 cm part was missing from there, so -1, 6 minus 1, that will be 5 cm. But initially when you are doing the measurement, you are measuring different objects. You will get the same kind of error. Every time with the same instrument, that 1 cm will be more in the measurement. So this is basically wrong calibration or due to some constant constant condition that is present in the measuring scale or instrument. So such error are due to faulty calibration of measuring scale of instrument or due to some fault in the instrument. So how can we minimize it? So the physical quantity can be measured number of times by different methods. Like if we have to measure the scale length of a body, then you can use different scales. So whatever be the difference will be there, you can get the result. So when you will take number of observations by different methods, and finally you will take their mean. So basically while doing the experiment, why we take the mean? So that due to any of the reason when you are performing the experiment, there may be slight variation, so average will be taken. So this is a constant error, and actually you can say that same error repeat again and again. Now next is systematic error. Systematic error. These error which arises according to definite pattern, in which certain definite pattern will be followed. Basically the cause of systematic errors are known and can be minimized by locating the source of error. Here we can easily locate that what is the kind of error and what is the reason of that error. So correction can be easily done. But this systematic error comes under different categories. So there are different types of systematic error. First of all, we are taking instrumental error. Instrumental error, that means this we have done in the previous case also. Many points you will correlate with each other. These errors occur due to inbuilt defect of measuring instrument. Like if wearing off the meter scale at one end. That means if it is not proper, then this will be under the instrumental error, and the same constant kind of error will be there in all the measurements. So this error can be detected by measuring a physical quantity with two different instruments of same type, or by measuring the same physical quantity by two different methods. So in the instrumental error, there can be some fault in the instrument. Now, next point is imperfection in experimental technique. Now, here when you are doing the experiment, there can be possible causes. That is in the different techniques which the person is adopting, that is not perfect. So these errors are due to limitations of experimental arrangement. So here as error due to buoyancy of air when we weight a body in air. Suppose we are measuring weight of any object and we know there is a concept of upthrust by air, by fluids. So basically when we are measuring weight, then the force exerted by air in the upward direction we usually ignore. So that is due to buoyancy, error due to buoyancy of air when we weight a body in air. That is negligibly small. But if we measure the temperature of human body, then what was the method initially done? That the thermometer was placed under the armpit and it will always give the temperature which was lower than the actual body temperature. So in this way we will always get the error in the measurement of actual body temperature. This is the experimental technique, imperfection experimental technique. So these can be the examples to explain the concept of imperfection experimental technique. Now the third type under systematic error is personal error. Personal error, this is all related with the person. That means if a person is performing, maybe the person is not mentally alert, maybe not taking care of all the precautions, maybe his carelessness, or he has not taken into consideration sources of error, or he has not set the apparatus properly. Many different reasons can be there for the personal error. So let me discuss these. These error arises due to inexperience of the observer. That means lack of knowledge. You don't know how to handle the things. Lack of proper setting of apparatus. Or carelessness in taking observations without observing proper precautions or sources of error. It means when experiment has to be done, then certain key rules should be there that how to perform the experiment and what precautions to be taken care of. So here if the person is not following all that, that will come under the personal error. Example. See, actually what happened in physics, it is always advised, suppose you are measuring a scale, measuring the length of any object with the help of scale. So if the length of any object is suppose 10 centimeter. So if I will just look at this point from the right side or the left side, I will place the object, let this pen is placed over it, and this measurement, if I will see just at the top, exactly I will just give you the knowledge of concept. If I will see exactly from the top, it will give, actually I am on the right, on the left side, so I am not getting the clear view. I am just turning it so that I will get clear view. It is giving me, this is your 13.8. This is 13.8. But if I will just look at from the left side or from the right side, there may be the illusion that the length can be 14. Actually the proper method, you will place its tip at 0 and just you will place it here. So you have to see directly above it. Don't put your eye on the left or on the right. This is first rule when you will come in the lab, which we will explain for measurement. This is not for the scale. This is for reading any of the apparatus, any voltmeter, galvanometer, ammeter, any measuring scale. When you are noting, then you have to keep your eye just above the reading point, not from the side. So when an observer holds his head towards right or left while reading a scale, he introduces some error due to parallax. So that is, what is a parallax? This is again a kind of error this occurs. So we'll discuss this in detail in the lab. Again, these errors can be minimized. How can we minimize such kind of error? If measurements are repeated by different persons or taking care of all the precautions. Suppose you're performing the experiment, the person should be mentally alert, he should take all the precautions, or if the same experiment has to be asked to be done by a number of persons, and then the corrections can be done, that the mean can be taken, that this is experiment, this is the pen and its length is whether 14 centimeter or 10 centimeter or 12 centimeter, the different persons will give different views. So basically the personal error can be corrected by taking number of observations by different persons. Now next is error due to external causes. What are external causes? External causes that can be in the form of temperature, pressure, outside the experimental setup. These errors arise due to change in external conditions like pressure, temperature, etc. Such errors can be minimized, can be detected, and necessary corrections can be applied. See, when you are performing experiments, if any physical condition may change, then there can be variation in the result. So now, systematic errors can be minimized by improving experimental techniques. If some imperfection technique was there, so that can be improved. Selecting better instrument. If some instrument is faulty, so then replace that instrument, and removing personal error as far as possible. So these are the different categories of systematic error. Next is random error. Another name for it is chance error. Actually, there is no proper reason for the random error, as the term indicates, the meaning of it, by chance, random, no certain reason. So these errors occur irregularly. Such error occur due to a slight variation in attentiveness of observer. Like, I can give you examples. Suppose you are attentive, you will get complete knowledge of the topic. But in between, if you are not focused, some point can be skipped. But next time, if you will watch the video again, then you will be attentive. So maybe that random, that means irregular, no proper cause is there why you are not attentive at that time. So I am relating like this. So the errors, these arises due to variation in attentiveness of an observer while performing the experiment, while taking the readings, or because of slight variation in experimental condition. In nutshell, we can say there is no particular reason for this kind of error. So how can we minimize it? Only the process is take the number of observations and take their arithmetic mean. So that's why this can be minimized by repeating the observation a large number of times and taking arithmetic mean of all the observations. Next is gross error. Actually, the gross error or the mistakes, we can say. These errors are due to either carelessness of a person, due to improper adjustment of the apparatus, or maybe wrong observations were taken, or sources of error or precautions had not taken into consideration, or if you have taken the measurement properly, set the apparatus properly, you are noting the observations and observations are correctly noted, but recording in the notebook is done, then it is wrong. If you have noted the value in the notebook wrong, then it will be just carelessness. So using wrong values in the calculations. So these are the mistakes which a person can commit, can do in between. So no correction can be applied for gross error, but it can be minimized only by our careful approach, by attentiveness. So we have to be mentally alert while doing the experiment. You can think that all these errors seems to be identical with the systematic error. I have previously said that all the errors are related with each other. But when we have to discuss them separately, so we will categorize them as separate now. Next is least count error. Least count error. This is a new term that we have to understand, because all the other error that was just correlated with each other. Actually, before understanding this least count error, we have to understand the meaning of least count. Least mane minimum, count mane measurement. So least count, that is the smallest measurement which we can do with the help of any measuring instrument. First of all, if we have to find least count of any scale you use in your geometry box, that is, judge it. It is 1 millimeter or 0.1 centimeter. So this is the least count of scale. If a wristwatch is there, where there is a second, minute and hour needle, so the minimum measurement will be 1 second. So 1 second will be its least count. So in a meter scale, the least count is 0.1 centimeter. So now this error is due to limitations imposed by least count of measuring instrument. What is the meaning? Limitations imposed by least count of measuring instrument. Suppose if I am taking, if I will write a number 2.0, 1, 2.0, 2.001. I'm just giving you just example, mathematical example of decimals. Out of these three values which I have written, this is up to 1 decimal place, this is up to 2 decimal place, this is up to 3 decimal place. It means we are measuring it more minutely. We are calculating it more minutely up to more decimal places, and we can do it up to more and more decimal places. So when we have to do the measurement, meter scale has a limitation that it can measure up to only 1 decimal place. Normal scale which we are using, we can do the measurement up to 1 decimal place. Suppose if this is a meter scale I am taking, this is 0, this is 1. For your understanding, I am drawing broad lines. Otherwise, the measurement will be not as per the scale. Now, if I am placing the object like this, what can be its measurement? 1.1 centimeter. Right? But if I will place any object which is lying in between these two, so can I take it as 1.1 or 1.2? Question mark. What should I take? Whether 1.1 or 1.2? Now physics gives you the concept how to measure this small measurement. But this scale has the limitations. It will either say it to be 1.1 or 1.2. In physics, we will always take that as there is no further subdivision in between 1.1 and 1.2, so the measurement will be treated as 1.1. But in actual sense, this small fraction, minute value, less than 1 millimeter, we are ignoring. But if we want to measure it correctly, what should we do? What kind of instrument we should use? See, this is the instrument. Here in class 11 you will use. This is vernier caliper. What you name it as? This is your vernier caliper. This vernier caliper, although I will not tell you at this point that how to do measurement like this, I have taken a book to show the experiment, but my purpose is not to just give you introduction about experiment. I want to tell you that this is vernier caliper. It has a least count of 0.01 centimeter, whereas a meter scale has a measurement of 0.1 centimeter, whereas vernier caliper has a measurement of 0.01 centimeter. It means with the help of this instrument, we can do measurement up to 2 decimal places. With up to 2 decimal places. Now see this. This instrument is screw gauge. SCREWGAUGE. Screw gauge. This is another instrument, again measurement for distance, for small measurement of length, diameter. And with the help of this instrument, we can do the measurement up to 2 decimal places. Up to 3 decimal places. Vernier caliper has given the measurement up to 2 decimal places. Here, it can do the measurement up to 3 decimal places. It means this screw gauge, out of these 3, it will give you more perfect measurement, more minute measurement. See, doesn't mean that the scale measurement is wrong, but it has some limitations. Vernier caliper is measuring up to 2 decimal places, but screw gauge is giving more perfect measurement. Suppose you want to measure the thickness of this paper. Very difficult to measure with the help of scale. You can either use vernier caliper or screw gauge. Screw gauge will give it better measurement because it's very thin. So in this way, we have related that out of different measuring instrument, different instrument have their other separate least count. So now what we have said about least count error, the error is due to limitations imposed by least count of measuring instrument. I think now it is clear to you what are the limitations, because scale has a limitation up to 1 decimal place. Screw gauge has limitation up to 3 decimal place and Vernier caliper has limitation up to 2 decimal place. So it is associated with resolution of measuring instrument. Now to understand it, so what we have done, that it is associated with resolution of measuring instrument. Resolution here means that we have to use the instrument of high resolution, that means smaller least count. So here least count I have explained of different instruments. Then least count error can be minimized by using instrument of high resolution, means up to more decimal places or smaller measurement we can do. So now least count errors are random errors but within a limited size. They occur with both random and systematic error. So least count error can be reduced by taking an instrument of higher resolution. So students, today we have discussed about error, different types. Although we have done theoretical concepts, now what you have to learn, that there can be the question that what can be the reason, whether it is corrected or not, how to do, what are the different kinds of error. So in the short note form it can be there. There can be 1 mark or 2 mark question on this. So learn these concepts, understand these concepts. So now revise the concepts carefully. So I am just completing all the work, just compiling. So now after that there is no new concept I will discuss. I am just recalling the concepts we have done: systematic error, random error, gross error, constant error, least count error. So thank you. Have a nice day.